Hello everyone. Today we are going to discuss an important topic from geotechnical engineering, site investigation. This belongs to the third semester of 2019 scheme of civil engineering and the fifth semester of 2015 scheme civil engineering. Site investigation is done for obtaining the information about the subsurface conditions at the site of proposed construction. We will be able to obtain the characteristics of soil at the site by doing site investigation. It is required in one form or the other in all kinds of big engineering projects. It consists of determining the profile of the natural soil deposits at the site by taking out the soil samples and determining the engineering properties of soil like shear strength, bearing capacity, optimum moisture content, etc. Next is the objectives of site investigation. This is an important university question and it was asked frequently during the previous years. First is to provide reliable, specific and detailed information about the soil and groundwater conditions of the site. This may be required for a safe and economic design as well as execution of the engineering works. Second one is to select the type and depth of foundation for a given structure. From the site investigation details, we will be able to know whether we should adopt a shallow foundation or a deep foundation. Third one is to determine the bearing capacity of the soil. Bearing capacity is the maximum capacity which the soil can withstand without undergoing failure. Then fourth one is to estimate the probable maximum and differential settlement. What is the maximum settlement and the differential settlement happening in the soil? Differential settlement means the foundation will be settling in a tilted manner. Then fifth one, to establish the groundwater level and to determine the properties of water. By determining the groundwater level, we will be able to know whether the area will be subjected to floods during rainy season or the pH of water. We will be determining the pH of water, its alkalinity, acidity and how it will affect the foundation strength. Then sixth one is to predict the lateral earth pressure against retaining walls and abutments. Retaining walls are structures constructed to prevent the falling off of hilly or raised areas. The lateral pressure, that is the pressure acting on the retaining walls from the sides, will be determined using the details obtained from site investigation. Then to select suitable construction techniques, that is whether we should adopt the most modern methods of construction or we should follow the conventional methods of construction. Eighth one is to predict and solve potential foundation problems. Ninth one, to ascertain the suitability of the soil as a construction material, that is if we can use it as a fine aggregate or a coarse aggregate. Tenth one is to investigate the safety of the existing structures and to suggest remedial measures. Is the existing structure safe or not? If it is not, we should suggest remedial measures. Then another important topic, guidelines for choosing the depth of borings. The depth of exploration is governed by influence zone. Influence zone means it is the depth which is influenced due to the application of superimposed loads. The depth of influence zone depends upon the type of structure, intensity of loading, shape and disposition of the loaded area, the soil profile and the physical characteristics of the soil. That is, if the foundation is square in shape or circular in shape, it will also affect the depth of influence zone. The depth up to which the stress increment due to superimposed loads can produce significant settlement and shear stress is known as significant depth. It is taken as the depth at which the vertical stress is 20% of the load intensity. Then we are coming to the depth of exploration for different kinds of footing. For square footing, the depth of exploration should be 1.5 times the width of the square footing. See from the figure, the width of the footing is B, but the depth of exploration is taken as 1.5 times B. In the case of strip footing, the depth of exploration is taken as 3 times the width of the strip footing. Strip footing is used to connect two loaded columns and the foundation will be in the form of a strip joining the two columns. Then in the case of raft foundation or closely spaced foundation. A raft foundation is in the form of a slab. It is a kind of shallow foundation. It will be acting as a foundation for the entire area. In the case of raft foundation, the depth of exploration should be 1.5 times the width of the entire loaded area. See, the width of foundation is B and the depth of exploration is taken as 1.5 times B. In the case of pile foundation, the depth of exploration is taken from the tip of the bearing, that is equal to 1.5 times the width of the pile group. If B is the width of the pile group, the depth of exploration is taken from the tip of the bearing pile and the value is 1.5 times B from the tip of the bearing pile. Next, in the case of friction piles, we will be dividing the length of the pile into 3 equal parts, and from the lower third point we will be taking the depth of exploration as 1.5 times the width of the pile group. See, from the figure we are taking the depth of exploration as 1.5 B from the lower third point, and B is the width of the pile group. What will be the depth of exploration of multi-storeyed buildings? It is governed by an equation, that is D is equal to C into S raised to 0.7, where D is the depth of exploration, C is a constant whose value is equal to 3 for light steel buildings and narrow concrete buildings, and is equal to 6 for heavy steel buildings and wide concrete buildings. S is the number of stories. Next is the spacing of boreholes. For small and less important buildings, there should be one borehole in the center. This is shown in the first figure. And for compact buildings covering 0.4 hectares, there should be 5 boreholes, 1 at the center and 4 at the corners. For large multi-storeyed buildings, there should be boreholes at all corners and also at important locations. The spacing between the boreholes is generally kept 10 to 30 meters according to the variation in the subsurface condition and loading. For highways, the spacing is kept between 150 to 300 meters. And an important point to note is that in highways, while taking the boreholes, we will be taking the boreholes along the ditch lines. In concrete dams, the spacing of boreholes is kept between 40 and 80 meters. With this, we come to the end of the slide. Thank you.